Testing. Alright, hello everyone, and this is the video about another two groups. Okay, the first, this is group 7, halogens, and group 0, noble gas. And for group 7 elements, we call halogens low. So we would commonly talk about the following four: fluorine, chlorine, bromine, iodine. Of course, acetylene is radioactive, just like the other elements that I've just mentioned before. These elements react with most metal to form salts, so they are called halogens because they are the salt formers. Okay, so we call that low salt and yim low, something like that. So this is what we will call that as halogens low salt. And what I would like to mention with you is on the properties. They are all poisonous. Okay, so that's why if you want, especially when you talk about chlorine, bromine, and iodine, it is commonly used as a disinfectant. Okay, disinfectant. So and I would like to talk something more about common points about the group 7 elements. Okay, which is they all have got 7 outermost shell electrons in the outermost shell. Just agree with the group number, group 7. And this group is very special because we have got the 3 physical states occurring in among those 5 elements. The first 2, they are gases. Bromine is a liquid, while for iodine is solid, acetylene is solid. While they are of very special color. Can you see that? Very special color. For fluorine is pale yellow. For chlorine it is greenish yellow. For bromine it is reddish brown. For iodine is black. For acetylene also black. So among the top 4, I would like you guys to memorize the color of them, and you are going to memorize the physical state and room temperature and pressure. Okay, so only non-metal liquid can be found here, right? So you may get from gas to solid, and this is reflected from the increasing trend in the melting point and the boiling point. Okay, that agrees with that too. Okay. So what are the physical states? As said before, they gradual changes from gas to solid when going down the group. So they are gradual change in the intensity of the color from pale yellow to black. Okay, gradual means not sudden. Okay, change it bit by bit, and intensity means then how dark the color is. Okay, from pale yellow to black. So you may see that, and they have low melting point and boiling point. And they are more smelly. Okay, and they are all poisonous. And also they are all poisonous. Okay, so this is what I would like to talk to you about the physical properties. How about the chemical property? What makes halogens different from the other elements? I would like to show you this diagram, this video.
In this experiment, we're going to test 2 unknown elements and deduce which one belongs to group 7. Bromine is a group 7 element. When sodium sulfite solution is added to aqueous bromine, what can you observe? The aqueous bromine changes from yellowish brown to colourless. Aqueous solutions of halogens turn colourless upon the action of sodium sulfite solution. We can use this test to determine which of the unknown elements belongs to group 7. Add sodium sulfite solution to 2 separate test tubes containing solutions of 2 unknown elements. Which unknown element, A or B, belongs to group 7? Element A becomes colourless when reacted with sodium sulfite solution, so element A belongs to group 7.
So for this video, we would know something more about the chemical properties of halogens, which is they will cause decolorization. Okay, they will cause decolorization with sodium sulfite solution, 亞硫酸鈉. So 亞硫酸鈉 it is a reducing agent, 還原劑, commonly found in some fruits, from some preserved fruits, or maybe wine, red wine. So we have got sulfite inside. So indeed, with that presence of this halogens, we react with sodium sulfite to cause decolorization. Decolorization means 褪色, so make it colorless. Okay, so the reaction is a little bit complicated. I don't expect Form 3 students will memorize this, just appreciate only. Okay, chlorine, we have water to form potassium sulfite, to form potassium chloride and sulfuric. The focusing point is on the color. Okay, chlorine is colored, or the other halogen is colored, but for the remaining, they are just colorless. Okay, including the product. The two product are colorless, so we will call it a decolorization. Okay, it's colored. Only this is colored, while the other is colorless. Second, they all react with metals to form compounds called salt. So this saying is just the complementary versions when you talk about group 1 and group 2 elements. And 3, the reactivity of these elements now this time it should be very highly noted that when you compare with metals, it increases down the group. But when you want to compare the reactivity on group 7 non-metals, this time decreases down the group. It is quite different. When you compare it with group 1 and group 2 elements, it is different, okay? It increases down the group. So this is what I would like to remind you. These two, they are different. Now, and so they will react with a hydrogen to give hydrogen halide. So this is the one of the sentence, right? This is what very, very important about this saying. And hydrogen to have chlorine to form hydrogen chloride, or you will want to have hydrogen react with iodine. So what will we get? Yes, that's right. We will call it hydrogen iodide. Okay, so the new compound, we call it iodine, not iodine, not hydrogen iodine, we call it hydrogen iodide. Now, the decreasing reactivity trend, so you may show it when you react with hydrogen, just like this. Okay, so this is what I would like to talk to you about group 7 elements. Now, I would like to spend some more time with you on the group 0 elements, noble gas. 貴氣體. So remember the naming of the term noble gas. Okay, so the 6 elements in group 0, they are called helium, neon, argon, krypton, xenon, radon. They are called noble gas because they rarely react with other substances, just like what we'll call it as noble, okay, 貴族. So they seldom react with other substances. Very, very stable. So the table below shows some of the properties of group 0 elements. The melting point, boiling point density increase standard group. Can you see that? Melting point, boiling point density increase standard group. So you may see that increase standard group, increase standard group, increase standard group, and all those they are gas. And what is so special is about electronic arrangement, except helium. All the others, they will have 8 outermost shell electrons, while for helium, just got 2. Okay, so this is a very special case. Very, very special. Now, for physical properties, they are colorless gas. Okay, at room temperature and pressure, very low melting point and boiling point. When you come with halogens, it's quite much different. For halogens, it is colored and melting point and boiling point a little bit higher than noble gas when you compare with the same period. Now, the chemical properties is very simple. All unreactive. Okay, they are unreactive. Why? It comes to our concern, how come group 0 elements, they are quite stable? So that stability, what we call it as an exceptional, 例外, so very, very high. Very, very high stability of the noble gas is related to the electronic arrangement. So as said before, the chemical property is related to the number of outermost shell electrons, of those atoms belonging to the elements, which means that for the noble gas, for the high stability, it is much related to the electronic arrangement, especially the outermost shell. So the non-noble gas, except helium, they have 8 outermost shell in their atoms. So we will call that the particle, they have great stability if they obtain an octet or a duplet. Octet means 8, okay? Duplet means 2, okay? 2 electrons in the outermost shell. So this one, it is for helium. The second statement, if you are going to explain how come helium is very, very stable, you are going to make that sentence. But if you want to talk about argon, okay, neon, argon, krypton, etc. So all those other group silver elements, you use the same, an octet of electrons in outermost shells. So they would gain what? Extra stability is gained. Okay, extra stability，例外嘅or exceptionally high stability 穩定性。Okay, so it's gained. So and for the other elements which are not group 0, so what will they do? They will either lose or gain or share electrons in order to make it stable, and will attain an octet and a duplet. Now you will know it in Form 4 chemistry. So introduce to you with the point how we're going to attain how it can be lose electrons, it can be gain electrons, or you can also even share electrons, and you can get this, and this is what we will know in Form 4. Now, the uses of group 0 elements is not related to the highly reactive character. So you may see that. So highly unreactive is also unreactive. So what is that? First of all, helium, it is used in to replace hydrogen, has a balloon and airship, right? Because for hydrogen, it is flammable, but for neon, it is not flammable, non-flammable when you compare with hydrogen. So it is a very good substitute of hydrogen. Okay, substitute for hydrogen because it has a low density. Okay, low density than air. For helium, point number the 2 reasons, right? One is non-flammable. The other reason is that it has a low density in air, so it flows. How about neon? Neon itself is colorless, but once I put it into a high voltage, to it will become colored. Okay, so it is used in a very old style advertising signs here. But of course, nowadays in Hong Kong, in even rare you seldom see it. We are now using LED. But for the old style neon light, okay, we will still use advertising signs. 3, and a very old style light bulb, incandescent light bulb, we will call it argon. So the filling gas, it is argon, filling gas in the tungsten light bulb. So nowadays, you know that we will not use the tungsten, we will seldom use tungsten light bulb. We use LED or the fluorescent light bulb. Okay, it's quite different. So because of that, you may know that because of the similarity in the chemical properties of those elements, we can use it to predict some other unknown, unfamiliar elements used based on the common point, okay, the common chemical properties in which they share. And I use this for you to predict which group those unknown or unfamiliar elements they belong to. And this is the end of the this part, and I would like to show you something more about the chapter exercise, right? Your supplementary exercise. Now take a look. Now page last part of the checkpoint. So Just wait for me. I would like to show you that one in the book, in the ebook. Now I'd like to show you guys the checkpoint. For the checkpoint for this one, you may show it here. The last few pages, the last two pages. This is on page, let me see, 61. So take a look on that. And again, you are going to do some prediction on that. What is the name of the group? Fluorine, chlorine, bromine. What is that? We call it halogens. So it's a group 7 elements. Okay, halogens. Name of the group. You need to spell the word. Spelling. So remember the spelling of the word. Chlorine is located in period 3, group 7 of the periodic table. State the electronic arrangement of chlorine atom and hence the atomic number of chlorine. You need to tell two things. 1. Electronic arrangement. 2. Atomic number. Okay? So the electronic arrangement for those halogen, it is much related to the atomic number because that atomic number 17 relates to the number of electrons as well. So the electronic arrangement for arranging those 17 electrons should be 2, 8, 7. Number 3, the atomic number of bromine is 35. Deduce the values of X and Y. So you need to do some deduction. So what happened to bromine? Bromine is located in where, right? Bromine, we have got 4 numbers. So we have got period 4, and they share in common. They are one of the halogens. So halogens, the last digit is what? Okay, it's 7. It's 7. So you may get those two information, and you can get the together with 35 atomic number, and you can guess what is the X and Y. Okay, so deduce推論. So you are going to give me reason. So underline the term deduce is located in group 7 period period 4. Okay, so it means that an bromine atom has 7 electrons in the outermost shell. So which means that Y is equal to 7. Together with X, what will we get? If you know that it's 7, this one is 7. Altogether, if there's 35, which means X, it is calculated as a subtraction of those numbers. 35 minus 2 minus 8 minus 7. So here comes 18. So here comes the electronic arrangement of bromine, 2, 8, 18, 17. Altogether 35 atomic number, right? So the properties of group 7 elements, they show the group trend 趨勢. So take the group trends shown by group 7 elements in there. First of all, boiling point. So the boiling point, the trend increases, while the reactivity, the trend decreases. So how will you describe that word? Now this is exam type questions. Okay, so I would like you guys to be very aware of it. So the way to write it down is the boiling points of group 7 elements increases down the group. So we're going to include group trend, right? Down group. So which means from top to below, I will observe it as increase. Okay? So this is what I would like to talk to you. How about reactivity? Similarly, can you write down something similar? Yes, that's right. So this is reactivity of group 7 elements. Well, I use downward arrow, right? So which means decreases down the group. Down the group. Reactivity of group 7 elements decreases down the group. Okay, so this is what I would like to talk to you about this one. This is for question 1. Question 2. Helium and neon. They are the group 0 elements in the periodic table. What is the name of a family of the elements in the periodic table? As I said before, this name should be, you should get the spelling, right? No guesses. So we'll draw the electronic diagram for the 2 atoms. The electronic diagrams means circle, right? For helium, how do we draw? Helium in the center, the electronic arrangement is 2. So right, so the 2 crosses, right? How about neon? It is 2, 8 for that electronic arrangement. So you stick back to neon, 2, and the other one, 8. 3, 4, 5, 6, 7, 8. Remember to pair up those, and you can get the full marks for that. It's easy, right? So helium and neon as examples suggest the meaning of the term doublet and octet electronic structure. So you're going to talk about helium, and helium atom has a doublet electronic arrangement. Because its outermost shell is completely filled with 2 electrons. Okay, 2 electrons in the outermost shell, doublet. So how about neon? And neon atom, how would it describe? It's not doublet, it's an octet. OCTET. Structure, electronic structure. Because of what? Because its outermost shell is completely filled with 8 electrons. 8 electrons. So the word octet will be that. That octet, it seems like the word octaves, right? In music, right? Which means 8, right? 8. So very similar. And D, explain why helium and neon are unlikely to react with other elements. Hi. As said before, extra stability, right, has been gained. Helium and neon are stable because their outermost shell electrons or electron shell okay, their outermost electron shell, what happened to them? They are completely filled with electrons. So this is very important, which gives extra stability. So this is what I would like to mention with you, completely filled with electrons, extra stability. So we call that that two gases, they are quite stable. Okay, so this is what I would like to talk to you about the very special point about the that two. Okay, first of all, we call that noble gas. Okay, it strips extra stability. I'd like to put it downward a little bit such that all of you can read it easily. Okay, so this is what I would like to talk to you about the noble gas. Okay, the noble gas, because it is helium and neon. They are very stable because the outermost reaction shell is complete. Remember, you need to write down outermost electron shell. They are completely filled with electrons, so they will give extra stability. So this is what I would like to remind all of you. Outermost electron shell. Okay, so this is what I would like to talk to you about group 7, halogens and noble gas. Now, just give you have a recap of all those by take a look on the concept map. So atomic periodic table in nowadays modern periodic table, they are arranged in the order of atomic number. While in the past, the Mendeleev one, they will use the increasing order of relative atomic mass. So quite different, but more or less they are very similar as a ranking. And at that time, they would Mendeleev, and now there's a modern periodic table. Also, they would like to group it according to the difference, the similarity in chemical properties in Mendeleev. But nowadays, you know that it is much related to the what similar chemical properties is due to what same number of outermost shell electrons. They have the same number. Okay, so we are going to have groups and periods. Okay, so in periods, a very simple saying from left to right, which means across the period. We'll use the term across period. While group, we like to use the word down the group, which means the direction is this. Our spirit's direction of this. So the metals, therefore metal change to what? Semi-metals or metalloids to non-metals. Or if you don't want to use that word, you use metalloids. How about the other here for group? That for main group metals and non-metals, you need to memorize the name. What are they? Alkaline metals, alkaline earth metals. For group 1 and group 2, how about group 7, halogens, and group 0, we call that noble gas. Noble gases. Okay, so for group 1, alkaline metals, they are soft metals, they are reactive. The reactive model to give what? Hydrogen gas. Hydrogen gas, H2. And alkaline solution, so we call it alkaline metals. The reactivity, similarly, with group 2, it is increases down the group. When you compare halogens, it is poisonous. Non-metals, they are reactive. The reactivity decreases down the group. It's different. How about noble gas? They are colorless gas. When you compare with this, halogens, they are colored. They are colored. You need to remember the color. And the very what? Reactive. Or what is that? Being very stable. Okay? So this is what I would like to talk to you about the periodic table. from Group 1, Group 2, Group 7, and Group 0. So this is what I would like to share with you, and I do hope you would start to appreciate the beauty of chemistry after taking a look on this chapter, periodic table. So very, very special. Let's enjoy the beauty of chemistry. And that's the end of this chapter. Bye bye.